I will present first some background and introduction to the presentation, then the technology basis of our systems, and shortly present some of the applications in the life cycle drilling simulation system, applications for planning, training, and real-time operation. Then we will present some case histories where our systems have been used with good results before we round up and finalize with conclusions. First, I will say some words about my own background and historical experience related to R&D and technology development and simulation. I have been involved in this since 1983. And up through the years, I've been in various periods looked into specific elements of drilling technology. I started out with looking into gas kick and well control development and control to understand, model, and develop simulators, and also combined this with experiments both in full-scale wells and in laboratory scale. So when I started, the single bubble models for gas percolation and rising were more or less the accepted industry standard, and now we have moved a long way over to accepting that the world is much more complex than this, and also that the realities of the process is implemented and reflected in the multi-phase simulators, which we now use for well control simulation. I also focused a lot on how gas kick develops in oil-based drilling modes. In the beginning of 1980s, there have been some very serious accidents and explosions in the industry offshore due to not understanding how gas kick was developing in oil-based mode properly. After this period, I went over to focus on drilling high pressure, high temperature wells and looking into what specific elements were of specific interest and high focus in these wells. I focused mostly on hydraulics and pressure control. For a period, I also studied well control and kick development in extended reach wells. Before I went over to deep water and ultra deep water drilling and worked for a period on extending the models and simulators which we have been working on before, and also doing verifications, both related to hydraulics, temperatures, and well control. And an example of one of these tasks is the rig you see on the down left-hand side, no right-hand side of the picture. This is a picture which myself took from a helicopter in the Campos Basin offshore Brazil, where I've been together with Petrobras personnel directing an extended 2-week experimental program in an ultra-deepwater well. This is the Deepwater Expedition rig. Then the industry started to focus more on other issues, or in parallel with deepwater drilling, they also focused on underbalanced drilling and managed pressure drilling. And I also dived into this area. Then my interest went more to integration of the system and how to utilize the modeling technologies in operations, and how to utilize this during real time. The next task was to develop automatic decision support systems, and now I'm focusing on how to utilize advanced simulations in the whole life cycle of well establishment, and also how to utilize this in drilling automation. I also want just to give some perspectives for you regarding downhole drilling simulations. The industry and academia started to look into this in the 60s, and this was closely related to also development of computing power and computers. The first simulators emerged in the 60s, and Amoco now part of BP, were pioneered this, and this effort was led by Keith Milheim, who is in fact, I think, still active in the industry today. And Amoco combined extensive modeling and simulations also with experiments. The picture you see here is a picture of a drilling simulator developed around 1980 by Insigth. It was called WellSim, and this was for its time a quite advanced simulator. Also, many PhD projects developed academic-related drilling simulators on several universities. Then, throughout the 80s and 90s, several R&D groups and industry groups went further to work on this. Amoco continued their efforts and their very good work. In Norway, Rolv Research developed several wellbore simulators in joint industry projects, and also utilized experiments in the Ulrik wells and Ulrik facilities for verification purposes. Around 1985, the two first dynamic kick simulators were developed and were published in SPE conference in Las Vegas. And Nickens published the model developed by Amoco, and Ekran and myself published the model developed in Rolv Research. Also, during this time, BP had an experimental effort developing what they called the wellbore fluids model, and this was also supported by extensive experimental setups in Sunbury. Schlumberger Cambridge Research developed the transient well control simulator, combining this with experiments. And in addition to this, more drilling related also, Sintef and IFE developed the Olga simulator, which mostly focused on multi-phase transport simulations, but also took care of the wellbore in the production phase. To continue, in the beginning, the first years, the drilling simulator were used by experts for planning special and challenging wells, and also for post-analysis if an incident had occurred, to explain what had happened and also to avoid doing this again. It was not implemented in the real operations. Around year 2000, some projects initiated at Rolv Research and Sintef in Norway started to develop simulation systems driven by real-time drilling data for the purpose of doing real-time decision support and real-time simulation, and also drilling automation. Around in 2008, eDrilling had developed their real-time decision support system, which is now called Well Ahead, and this also had an extensive 3D dynamic downhole visualization capability. In 2010, a new milestone was reached in the downhole simulation story. At that time, the advanced downhole simulator Intellectus was linked to an advanced topside simulator, so that now you could train drilling teams and drillers with feedback from a fancy advanced dynamic simulator representing the real conditions in the well. Then in 2013, the first full life cycle drilling simulation system was developed and delivered, and from that on, utilizing this concept, life cycle drilling simulation has been growing in the industry. And I'd like to end this historic story just by showing you the pictures you see on this slide, which are pictures from today's WellSim, the WellSim Interact Engineering Drilling Simulator, which recently was released in eDrilling. And here we have the drilling control panel, which is specially designed for engineers, and we have an interactive interface also with 3D visualization and also plotting capabilities. The ultimate vision for drilling simulation, I have, for myself at least, I have written down here. This is to have a transient integrated drilling simulator which models all the important drilling sub-processes, which also comprise transient flow modeling with single and multi-phase capabilities, coupled to a transient wellbore thermal model, have a drill string and vibrational models, ROP models interacting with mechanical earth properties, and also a mechanical earth model including 3D geological, geomechanical and reservoir models. All these visualized in the 3D virtual reality environment. Also part of the vision is to have this enabled for planning, training, real-time and post-operations, so that you have a full life cycle drilling simulation system. And finally, also to utilize this simulation system for automation of the drilling process. We have implemented kind of some of this vision in our roadmap, and we are here on the lower end of this roadmap today. We are currently implementing dual gradient drilling fully in our systems. And working on pore pressure, wellbore stability and steady state hydraulics, and we will gradually work towards the end of the road here, where we have the fully automated drilling as the end goal. The key technology, or one of the key technologies, is what we call the virtual well, and the virtual well is a collection of advanced mathematical models linked together in an integrated drilling simulator. And these models are hydraulics model, temperature model, the torque and drag model, rate of penetration model, wellbore stability model, and pore pressure model. We also have an infrastructure which links these models to the environment, so enabling these models to be used for training, for real-time operation, and also for planning on the same virtual. And finally, we have the visualization system, the virtual well itself, where we can make what is invisible for the driller today visible right ahead of him. We can move the focus from topside to downhole, and we can also have all the risk elements pictured on this screen. And this is a very good tool to communicate the risks to all the personnel involved. To summarize, what we now have is a full life cycle drilling simulation system consisting of planning models. You can do what-if evaluations, you can do dynamic planning of hydraulics and so on, well control, torque and drag. Then we can take the same wellbore over to a training environment where you can do training of your drilling teams. You can test new technologies in this virtual wellbore, but you can also utilize this for interactive drill well on simulator engineering purposes. And finally, you can also take the same data seamlessly over to the operational phase, where you do the real-time support service and monitoring of the wellbore. And the simulators are then calculating in real time and are driven by real-time drilling data. And we also utilize drilling data which are measured downhole in the well to recalculate and calibrate the models. The real-time system also does automatic real-time look-ahead evaluations. You can do what-if calculations by extracting the calibrated model from the operation and do various what-if evaluations based on the calibrated real model of the well. The system also provides decision support and diagnostics, and the operational and the training elements are both provided with the advanced 3D visualization system. Briefly, I want to mention the product themselves. The planning system, we call it Well Planner. It has a number of applications: dynamic hydraulics and temperatures, well control, evaluation and optimization, kick tolerance, torque and drag planning, and you can also link pore pressure and wellbore stability planning into this model. Then we have the real-time system well ahead, and this performs real-time simulations and decision support. This system will promote a proactive and not a reactive approach to the drilling operation. Today, the industry very often kind of they don't wait for the troubles to happen, but they don't have too many active possibilities to intervene on a real solid basis. This system will give this kind of opportunity. It also makes automatic supervision of the drilling window. You can automatically update pore and wellbore stability during drilling, and it also provides diagnostics and warnings on a number of key parameters which are related to the technical quality and also the safety of the wellbore. The system also gives, as I mentioned previously, automatic look ahead of ECD and of the torque drag. And the calculated pressures are de facto a virtual PWD, since these models calculate the pressure profile in the whole wellbore at any time in the operation. Also, when you don't have when you don't have any sensors functioning. Then we have the large-scale simulator, which has been used a lot for training drilling teams. Here we have linked the Oiltech Hydrill topside simulator to the downhole model, and this provides the possibility for the drilling teams and for the service companies involved in the operation all sit together in a very realistic environment and train on problems which are simulated by the simulator. This is a kind of a drilling flight simulator, you could say. Now we have an engineering version of the drilling simulator, which has the main focus to do interactive engineering, and it has a very simplified topside where the engineers can do interactive controlling the well. But apart from that, the rest of the interface is the same as of the other simulators. These models have been used by a number of customers so far, listed to the right. It has been used during real-time operations, for planning and designing operations. It's been used in managed pressure drilling, closed loop control. It's been using it's been used and is being in use extensively for training drilling teams, and we have experienced more than 100 well-specific training scenarios focusing on a number of well types and problem areas in our kind of library of cases. Now I will focus, the next part will be to look into some of the cases where the systems have been running. And the first case here is the Martin Linge or Hild well, which was drilled some years ago. In this well, the wellhead system was installed and tested and demonstrated. It was not used actively by the operator, but the operator, they used their traditional normal procedures, and at the same time the wellhead was fully installed and gave advice in order to be able to compare what would have been the results of the real well versus if the advice from the wellhead system had been taken, what they could have achieved. And during the operation, the main focus areas were real-time modeling of ECDs, pore pressures and wellbore stability, all updated by means of downhole measurements during the operation. Here is an example of this plot shows from the 8.5-inch drain hole, and it shows that the pink, which is the pressure while drilling sensor data, there is periods where there are no results from this, and in these periods the blue, which is the calculated PWD data, they are still functioning, of course, and when the sensor comes back, it's spot on what is predicted by the model. So this illustrates the value of such a model. It can be used as a virtual PWD, and you can avoid to pull out the hole in specific cases. And this we have experience also in several wells. On this well, we made a summary together with Total, and this slide kind of summarizes the value which could have been achieved. But overall, we came to the conclusion that about 2 weeks of rig time could have been saved, and also a lot of materials, and also the well integrity of after the well was left could have also been greatly improved if the advice from well ahead had been taken into account. There is a paper, a reference paper of this study made by Total and ourselves.
Next one, it takes us to China, CNOOC. This is the setup of training, planning and support center in Tianjin. You can see this large curved screen, 2 drill chairs, some feeder-like seats behind. It's all integral part of high drill well simulator. On the right side, you can see also the rooms equipped with real-time and with training software. Okay, this diagram shows the way the product, eDrilling product, has been implemented and used so far. When RTO center in CNOOC receives a well to monitor, they would use this well ahead software to support it 24/7, coupled with a visualization, 3D visualization. At the same time, another group of engineers will be focusing on planning and optimization of the current well that is being monitored, and also on handling the request from drilling supervisor offshore. Simultaneously, the teams of drilling supervisors and offshore personnel will be trained using the WellSim high drill. But now, since the CNOOC realized the benefits of WellSim Interact software, they shown interest into acquiring it, and later it will just complete the full well life cycle simulation concept. That's it from me.
Yeah. We have also a very interesting case history in cooperation with Wintershall. I will not dwell much on this. There's been a separate webinar focusing on this, so you can go into the link of that. I just summarize that Wintershall was very satisfied, and they estimated about 19 days saved on this well, which was an HPHD prospect in a very narrow margin area. And 2 SB papers have been prepared and going to be presented early next year. And here you have also the link of the webinar on the IMSA well case. I'm trying to finalize the presentation by giving some recommendations to the industry. Today, the times are somewhat difficult. The oil prices are fluctuating and quite low. However, some of us have been involved in the industry for a long time, and we've seen that what goes down very often comes up again. But anyway, I'll try to give some advice and recommendations. And the first one is to maintain and enhance the safety focus which the industry has had lately, and not let the present price dip influence on safety. That's very important. And you should maintain and also enhance the standards related to well control training, and also training related to technical incidents with a high risk potential. It should be unnecessary to mention the Macondo, but I've also been for a long time in the industry, and I've seen that Macondo is not the first time there's been a big incident in the industry. And what sometimes happens is that after some time, especially those who count the money in the oil companies, they tend to forget these very important learnings. The next point is to expand the use of high fidelity training simulators with advanced modeling of the downhole process. I think this is also linked to the first point. And now the most advanced simulators in the world are available at the most training centers around the world. The third point is that I would advise the operations to train on your own well and your own formation. And this gives a very realistic fingerprinting response. And we should not forget that every well, also the so-called straightforward wells, are potential disasters. The next point is that during operations one should try to implement and maintain a proactive attitude by using real-time simulation and decision support systems. And this will reduce the number of serious incidents and enhance the general safety picture. During planning and operations, 3D well visualizations should be used to communicate risk picture across the various teams. There are probably also a number of other technologies which could be used to maintain focus on the risk picture during the operations. And also the last point on the safety issue is to continue to move towards the automation, and part of that is to remove control of critical sub-operations with a high failure potential, to remove these from the operator or driller, because there is still a potential for human errors, and if this can be removed by combining modeling and automation, it should be done. The second point is the cost issue. We should train new engineers first to utilize life cycle simulation systems, and when they are up and running on these, I think the industry can harvest lower costs. Next, you should streamline your well planning processes by analyzing and modifying today's work processes and implementing novel tools into these. The third point is to utilize forecasting simulations so that the operations can be prepared on what you can expect, what you really can expect, based on the physics of what is down there. And you should do what-if simulations during operations according to needs in order to optimize the operations ahead. Also, to save cost, you should be proactive and utilize the tools which are relevant for enhancing and increasing the way to proactive. And in wells with narrow windows and high uncertainties, the industry should also utilize the possibility to do real-time modeling and updates of the drilling window, meaning the pour, the fracture and the collapse gradients ahead of the bit. This will both save costs and enhance safety. So finally, to conclude this presentation and this webinar, the first point, advanced downhole drilling simulators have come a long way from R&D and expert tools in the 1980s to today being integrated in operational support and automation. And the final simulation vision is approaching. Real-time data-driven modeling and decision support has been used with good results in very challenging drilling operations. And significant savings and reductions in non-productive time have been achieved in these cases. And finally, by combining transient modeling in the whole life cycle of well construction, from planning through training, real-time operation and lesson learned, doing this you can generate lower costs and increase safety. So that concludes the webinar, and we are now open for questions.
Yeah, you have the possibility to ask questions in the user interface of this webinar, and we already have a couple of questions, so we'll just start with those. Well, first question, I can see that DGD is included. What is the eDrilling work and state regarding MPD controls?
we are not ourselves developing our own control systems, but we are modeling the dual gradient process and the MPD process, and both our well planner and our WellSim Interact and also our well ahead system can operate during such operations. However, we work together with any vendor of full MPD or DGD systems and offer the possibility for them to use our advanced modeling systems and also our well ahead system in order to control the bottom of pressure, control the choke setting, and also to supervise the operation by means of these systems. And we have been working with several companies. Have been involved with enhanced drilling for prototype development and are discussing with them. Halliburton is a very important cooperation partner where they in Scandinavia use our models in their geobalance system. And also we are working closely now with Chevron in order to the first phase will be to develop engineering training systems for them so that they can train their engineers and also train on the well controlled procedures and so on. But eventually we will also probably work on implementing the models into the full control system. But that is for the future in that case.
Okay, next question. How would you describe the differences from what you can offer compared to other real-time providers?
First of all, I would say that we are advocating that all providers of real-time systems which have a good and technology sound products have success. I think any part's success will also help the other parts, because this is an emerging business. When that is said, the main focus of our system, or the main unique things, is that we have one element is that we have the virtual wellbore, which makes a very simple way of summarizing the wellbore status, the risk elements, and also the results of the real-time modeling. A picture is 1,000 times better than a curve or 1,000 words or whatever. That is the first element. The other main element, I would say, is that we have developed a real-time system to be seamlessly linked also to planning systems and to training systems, so that if you are in a real-time operation, you can then take the calibrated model of the well into planning or doing what if, or into training, so that you can even train on the fly. That's the two most important things.
Okay, we are short of time, but we can take a couple of more questions. Let's take this one. Hi, I seem to be only. Do you see the simulator being used to generate expected drilling curves in advance, which can be plotted alongside the actual curves when the well is being drilled? For example, pressure losses, mud weight, torque, drag, and so on.
Yes, we foresee that, and this is in fact also being done for some of the parameters, and also others will be implemented, because we are in fact calculating these curves today. It's just a question of visualizing these, but for the torque drag we're doing this currently, and also for some others.
Okay, let's take this one. Can you say in a few words what is the industry status on a global level of dynamic drilling simulators of similar capacity to what you have talked about today?
I would say that today the industry status is that If you look at the, well, again, I don't want to say too much on our competitors, but what is unique with our system is that we have managed to link advanced transient integrated downhole simulation to a topside simulator. And this has been a very challenging task. I know that other actors have been trying very hard to do this, but when you're operating on a transient model, stability is a key issue, and to achieve a stable condition when you have a driller who operates everything, or when an engineer is operating the interactive panel, that is a very big challenge, and we have managed to solve this. And there are no other in the industry currently who have done that. Apart from that, I think in the planning domain, there are also not many, but I think one other company, one of the big players who have some similar things. And on the real time, there is another actor who has elements of what we have, but not the complete picture. And there are no elements in the industry who have all these integrated into one seamlessly into a life cycle system.
Okay, we can have another question. Have the models contributed to ordinary well control theory and any changes in these? Basing this on the possibility to avoid the single bubble theory you mentioned.
This is an interesting question, because for people who have been involved in well control training, and the people who have been involved in research and detail engineering, historically there has been quite a long distance between these two environments. What we are trying to do is to merge these two, so that what has been the kind of the scientific and the R&D environment in the oil companies and universities, what they have seen the light, or they've seen the truth or the reality, that this is also coming into the training environment. And I think gradually it has started to emerge, but I think unfortunately still some places, some of the basic well control training is based on the single bubble model, unfortunately.
Okay, we are 10 minutes on overtime, so I guess we are out of time. I would like to thank Rolv and Alexey for this webinar, and all of you that has joined us today. We will publish this webinar on our YouTube channel later on, so you can look again. Thank you all.
Thank you.